So we're looking at an absolute value problem. Y is equal to absolute value of x minus 1. And then you have x squared minus 3. And then x is equal to 0. What's the visualization look like? How do we visualize the absolute value of x minus 1? So let us take a look at our graph. This is my x-axis. This is my y-axis. So graphing x squared minus 3 is not that difficult, right? If we were to graph x squared minus 3, we just move 3 units. What happened here? Down here. Let me just regraph this. Today is one of those days. Okay. So here, -3. So this is the graph of x squared minus 3. And then the graph of absolute value of x minus 1, you're shifting the absolute value 1 unit to the right-hand side. So let me use a different color for this. So this is your absolute value of x minus 1 with the graph here. We are looking for the area bounded between these two when x is equal to 0. So when x is equal to 0, we look at the y-axis. This is x equal to 0. So basically, you want to know what is this area? How do we calculate this area? Very good. To calculate this area, let us divide this up into 2 portions, right? Why is that? Take a look. On one side, on the left-hand side, the absolute value function is on top here, and down here you have x squared minus 3, and then on the other side, absolute value function is just right here, and then you get x squared minus 3 down here, right? So basically, your job is to analyze your absolute value. Otherwise, you get a wrong answer if we just get rid of this absolute value without analyzing it. So y is equal to, if x is more than equals to 1, you get x minus 1 back. And when x is less than 1, you have to put a negative sign in front of your absolute value. So your area can be written as the summation of two integrals. On top, the ceiling that you have on the left-hand side, you have negative x minus 1. And here, the ceiling on the right-hand side, you have just x minus 1. That's why we divide this up into 2 integrals. Perfect. So the integral between 0 and 1, the larger y value is negative x minus 1 minus x squared minus 3 dx plus, and then we start at 1. Where should we stop? What's the intersection between these two? You know that x squared minus 3 is equal to x minus 1, and you can write it as x squared minus x minus 4 minus 2, so 1 to the other side. So let me just fix this for you. Minus 3 is equal to 0. And let me just add that here without doing any algebra, further algebra. Minus 2 is equal to 0. Very good. So you can use factoring here, or basically use quadratic equation to solve this problem. As we saw before, you can calculate delta, which is b squared minus 4ac, which is 9. So as you saw, x is equal to negative 1, which is positive 1, plus minus square root of delta divided by 2a, or 1 plus minus 3 divided by 2. So x is 4 divided by 2, or 2, or x is equal to negative 2 divided by 2, which is negative 1. So this value, the intersecting value, is going to be 2. So from 1 to 2. From 1 to 2, the top function, the larger y value is x minus 1, minus the smaller y value is x squared minus 3 dx. Very good. So a is equal to the definite integral 0 to 1. Let's just distribute x into parentheses, minus x squared plus 3 dx. The same here, plus the definite integral 1 to 2 x minus 1 minus x squared plus 3 dx. Very good. So a, or the area, is the definite integral 0 to 1. You have negative x minus x squared plus 4 dx, plus the definite integral 1 to 2 of x minus x squared plus 2 dx. Now we just need to find these integrals, do the substitution, and calculate the area. So area is equal to the integral of negative x is negative x squared divided by 2. The integral of x squared is x cubed divided by 3. And the integral of 4 is 4x, and x ranges between 0 and 1. The same for this guy. The integral of x is x squared divided by 2. The integral of x squared is x cubed divided by 3. And the integral of 2 is 2x, and it is ranging between 1 to 2. Perfect. So your a is equal to, let us plug in 1, you get negative a half minus a third plus 4. And if you plug in 0, everything becomes 0. So I'm not really worried about 0 over there. Plus, and if you plug in 2 here, you get 4 divided by 2 minus 8 thirds plus 4 minus, when you plug in 1, you get a half minus a third plus 2. So let me separate this. And go back here. So my area is equal to, I have negative 5 divided by 6 plus 4 plus, so you have 2 plus 4, which is 6 minus 8 thirds. And then you have minus, if you plug in, if you take common denominator between these two, you get 1 over 6 plus 2. More algebra for you, everybody. Negative 5 divided by 6 plus 10 minus 8 divided by 3 minus 1 over 6 minus 2. Well, here, if I take common denominator between these, which is 6 itself, I get 8, and the common denominator 6. So here, if I combine these two, I get negative 6 minus 16. So I have 8 minus 22 divided by 6, or if I take common denominator, 48 minus 22, which gives me 26 divided by 6, or 13 divided by 3. for the integral including absolute value.